In this video, I am discussing the numericals based on electrochemistry, that is mainly various types of conductance in ionic solutions. Right? So please watch the video till the end and practice the numericals. Right? But before we go in for the numericals, we will just look into the formulas which are required for solving the numericals. So I've just jotted down all the formulae and their units. See the resistance. Resistance is rho L by A. Then L by A, which is cell constant. We represent cell constant by G star. Then inverse of resistance is conductance. So 1 by R. If you do 1 by R, this whole thing gets inverted. So you have this as 1 by rho A by L. And 1 by resistance is conductance. G is conductance. 1 by specific resistance is specific conductance. That is represented by kappa. Okay. Then L by A was cell constant. So instead of L by A, I wrote here cell constant. At times, you will also have a relation with resistance and cell constant. So then you can use this one. Cell constant is equal to RK. R is resistance, K is kappa. That is conductivity. Right? Then you have molar conductance also. All these details about each type of the conductance I've already shared, in the videos under the heading Electrochemistry. Playlist is made. You can just watch all the videos before you do the numericals, right? So you have lambda m is kappa into volume. Then lambda m is 1000 kappa by m, that is molarity. And this is limiting molar conductivity. Limiting molar conductivity, that is applying Kohlrausch law. It says the sum of the limiting conductivities of the cation and anion is the total electrolyte's conductivity. And then degree of dissociation, alpha. Alpha is lambda m at given concentration divided by lambda m at infinite concentration. That is limiting molar conductivity. So at times numericals are also asked based on this. And then the dissociation constant, where Ka is alpha square C, where C is the concentration, molarity, by 1 minus alpha. At times alpha is very less in comparison to 1. So 1 minus alpha can also be taken as, 1 minus alpha can also be taken as 1 only. And you can write down this as just alpha square C. Ka is equal to alpha square C. So you can even use this as the direct, shortcut. Right? But in case you want the accurate answer, you should be using 1 minus alpha also. So just have a look at the units. Resistance is given in ohms. Specific resistance rho is ohm centimeter. Then this length and area. Then conductance is per ohm. Per ohm is also read as Simon. Per ohm is also written as Simon. Another unit for conductance. Specific conductance is per ohm per centimeter. Instead of per ohm, as I said, you can also write Simon per centimeter. Then too it is fine. Then cell constant is per centimeter. Then lambda m is Simon centimeter square per mole. So be familiar with all the formula. So all these are in your screen. At present, you can just take the screenshot and note down, or pause it and note down all the formulas, right? Before proceeding for the numericals. Now let's do the numericals. Now first, read the question properly and write down the data which is given in the question. It says the resistance of this much molar solution is here. So resistance is given. Note down resistance. Resistance is 5.55 into 10 to the power 3 ohms. That's given. Concentration is given. That is molarity is known to us. That is 0.05. Right? This much molar. Then you are given the diameter. The diameter is given. Now, using this diameter, we will be calculating area, because in the formula we know that we require area. Right? So the area of the cross section of the column is given by the formula pi r square. Pi r square. Right? So when diameter is known, what will be the radius? Half of it. So we'll put the value for pi 3.14 into 1 centimeter was given. So it is 1 by 2 and the square of it. So when you solve it, you get the area as 0.785 centimeter square. This is the area given. Right? Then the length of the column is given. Length of the column is given as 50 centimeter. You are asked to calculate three different things. One, you are asked to calculate resistivity. Resistivity is rho. Rho includes, we wrote the formula, rho is equal to R A by L. You have everything known here. R is 5.55 into 10 to the power 3. Put the value for area, 0.785 divided by, what is the length in this? It's given as 50 centimeter. So you have to just multiply and divide, right? So when you do this, you get the rho value as 87.135 ohm centimeter. This is one thing, this is calculated. One part is done. Rho is done. Then we are looking for the calculation of conductivity. That is very simple. We know kappa is equal to 1 by rho. So just we have to do this. Kappa is equal to 1 by rho. So that means 1 divided by this value, 87.135, right? So when you do this, you will get it as 0.01148 Simon per centimeter. This is what you have to do. Okay, so the second thing also we have done. We have calculated the kappa value. Right? Now we are looking in for the calculation of lambda m, that is molar conductivity. Now what is molar conductivity formula? Lambda m is equal to 1000 kappa by molarity. Now you have that kappa value we just calculated, 0. This is the value we got it here, 0.01148 divided by molarity is also given in the question, 0.05, right? And you will have to just multiply and divide here, 229.6 Simon centimeter square per mole. Do not forget to write the units. If you do not write the units, you are going to lose mark for that. Please make sure the units are also written, right? So this was the first numerical. The whole thing is in your screen at present. Please note it down. Moving on to the next question. It says the resistance of some conductivity cell is given, and when the cell is filled with this much solution, and when it is filled with 0.02 molar, the resistance is some other value. Calculate kappa lambda m of the second solution, and for the first one they are saying the kappa value is given. Let's write the data first. First is 0.1 molar KCl, second one is 0.02 molar, right? This is the thing first. This is this much solution, right? For the first one, the resistance is given as 100 ohms. The second one, the resistance is given as 520 ohms, right? For the first one, the kappa value is given. Kappa value is given as 1.29 Simon per meter. For the next one, for the second solution, the kappa and the lambda m both are to be solved. We are asked to calculate. So first, what we do is, read the question. Same cell. It says the cell is same. When the cell is same means the cell constant has to be same. Right? The cell constant has to be same. The first is you solve the value for cell constant. The cell constant is equal to R into kappa. So R was given as 100 ohms. For the first one, whatever data is given, you note down. When you solve it, you will get it as 129 Simon. It is per meter. Now cell constant, so per meter, only per meter. Cell constant is known now. The cell constant remains the same whether it is filled with the first solution or the second solution. So that means the same cell constant value we can use here. Same cell constant value can be used here. Now what is the formula for that? Kappa we are asked to calculate. Kappa is equal to cell constant divided by the resistance. That is, this was equal to RK we said. So the same formula I have used here. But now I am using it for the second thing. For the second cell. That means you calculate from the first cell, what is the cell constant, use the same cell constant value for the second one. and calculate what is kappa. The cell constant we just calculated 129. Resistance is given as 520. Now you solve it. It comes out to be 0.248. This is kappa, so that means it is Simon per meter. Still we are using in meter only. Right? So this is Simon per meter. Then this part is done. We are now looking for, we have calculated the kappa value. This part is done. We are now looking for the calculation of lambda m. The formula which we are normally writing, lambda m is equal to 1000 kappa by m. That is Simon centimeter square per mole. Just mind it, we multiplied with 1000 to convert into centimeter cube. Volume 1 liter we converted into centimeter cube. So that means this kappa value also we will have to convert into centimeter in order to use the same formula of 1000. So we can convert this as 1000. You have already. This much Simon per meter is equal to 0.00248. Why? Because it is per meter. It is not to be multiplied. It is to be divided by 100 now. It is to be divided by 100 so as to convert into centimeter. Divided by, what is the concentration given? 0.02. That's it. You will have to solve it. You will get it as 124 Simon centimeter square per mole. This is the answer for the question. Just see, I hope this part is clear. If you want, you can calculate this one also in per centimeter. But here it was not required because here there is no mixing up of the units. So here we are, because 1000 we have already written. So we have to convert the other one into centimeter. Okay. Yeah, moving on to the next question. We have resistance of decimolar. Decimolar means the molarity is given as 0.1 molar. Resistance is given as 245 ohms. We are looking for lambda m calculation, where the distance is given as 2 centimeter and the area is given as 3.5 centimeter square. Right? So we do not know lambda. For lambda m we need kappa also, because we know the formula for lambda m as 1000 kappa by m. We know molarity. We do not know kappa. First we should be calculating kappa so as to substitute here. Right? So first let us calculate the kappa value. The formula for the kappa is equal to 1 by r into L by A. Okay, you can just look into the formulas which I gave you in the beginning of the video, and then you can just put the values over here. So what are the values given here? We can just put the values. It is 1 by 245. L is 2 divided by 3.5. Right? So this is the first half, wherein we are asked to calculate kappa. Right? So now we can use this kappa value here. We can have here lambda m is equal to 1000. Either you first calculate kappa value here and then put it here, or you can just put it in this as such, as 1 by 245 into 2 by 3.5, and this molarity is already given here as 0.1 molar, and just calculate what is the lambda m value. It comes out to be 23.32 Simon centimeter square per mole. This is the lambda m value. Just see the question is clear. Now moving on to the next question. It says the limiting molar conductivity of these three electrolytes, NaOH, NaCl, barium chloride, is given. The units are same, Simon meter square per mole. This is given in Simon meter square per mole instead of centimeter. And calculate the lambda m naught for barium hydroxide. Right? One shortcut in this. You just see for what are you calculating. Barium hydroxide. Compare the electrolytes with for what you are calculating. Which electrolyte is not having any common ion with this? This has OH common with barium hydroxide. This has barium common. This one is not common. That means the other two you will be adding and you will be subtracting this one. In a way, you are applying Kohlrausch law only. So lambda m naught for barium hydroxide is equal to lambda m naught for barium chloride. That you can keep it first. Then you can have lambda m naught for this thing NaOH, right, minus lambda m naught for NaCl. Now one thing, this will give 2 OH, this will give 2 chloride. That means we need 2 OH and 2 chlorides also. So what you do is, you'll have to multiply this with 2, you'll have to multiply this one also with 2. So as you get 2 OH and 2 Cl. And 2 Na will get cancelled finally. That will not create any issue. So when you add these conductance of these two and subtract it, you will be getting the conductance only because of 1 barium and 2 OH. Because Na and Na will get cancelled, chlorine and chlorine will get cancelled. Because each ion is contributing to the total conductivity. Now you'll have to just put these values over here. That is 2.8 into 10 to the power minus 2 for barium chloride, plus twice that of NaOH, 2.48 into 10 to the power minus 2, minus twice that of NaCl, 1.265 into 10 to the power minus 2. So you have to just now calculate. So when you solve this part, comes out to be 5.232 into minus 2, 10 to the power minus 2 Simon meter square per mole. Clear? Now moving on to the next question. This one. It says that molar conductivity for NaCl and KCl are given. For Na is given separately. For potassium they are asking. So again, it's an application of Kohlrausch law. When you know the molar conductivity of NaCl and that of Na, you can calculate the conductivity of chloride ion as molar conductivity of NaCl minus that of the conductivity of the sodium ion. Yes, so we have to just put the value 126.5 minus 50.1. 50.1, that will give you that of the conductivity of the chloride ion. Yes, so this part we will solve. So it comes out to be this for chloride, 76.4, right? This much is for chloride. And now in order to calculate the conductivity of potassium ion, we will be having the molar conductivity of KCl minus the conductivity of chloride ion. That means 149.9, which is given in the question, minus that of this thing chloride, which we calculated. Of course the unit we could have written this much Simon centimeter square per mole. And when you solve this part for 76.4, it is 73.5. It is Simon centimeter square per mole. This is your answer. So it's one of the application of Kohlrausch law. Okay. Yeah. Now the next type of question. Kappa is given. This is the kappa value given. Concentration is given. Calculate lambda m and Ka value. Ka is to be solved. Okay. Now what will be the steps in this? First thing is, you'll have to calculate the lambda m at given concentration, at this concentration. For that you have the same formula, 1000 kappa by m. You can just put the values here, that is 1000, and the kappa value given is 7.896 into 10 to the power minus 5, and molarity is 0.00241. So this is lambda m at given concentration. So which comes out to be 32.76 Simon centimeter square per mole. This is lambda m at given concentration. Then we need to calculate Ka. Ka is equal to alpha square C. But for that we require alpha. So alpha is equal to lambda m at given concentration by lambda m at infinite. Right? So infinite is given. Lambda m at given concentration is 32.76 by 390.5. You solve this alpha value. It comes out to be 0.084. So now because it is much lesser than the 1, we can neglect this lower part and we can just write alpha square C. So 0.08 this square into what was C value? 0.00241. So when you solve it, it comes out to be approximately 1.85 into 10 to the power minus 5. This is the Ka value. Got it? Right? Yeah, moving on to the last question. It says the kappa value is known. This is kappa value. Calculate solubility. Solubility is concentration, but it's given in gram per liter. So we are looking for this gram per liter. Okay. And lambda m for ions are given. So first thing is we will calculate that lambda m naught for AgCl. That is the sum of these two. That is 61.9 plus 76.3. When you add up 76.3, it comes out to be 138.2 Simon centimeter square per mole. This is lambda m naught value. Now, using this lambda m naught value, we will be calculating molarity first. So, you have the formula that lambda m naught is equal to 1000 kappa. Actually, lambda m only, but since it is for infinite, we are using the same as lambda m naught here, molarity. So, we can put all the values and calculate molarity over here. So, molarity is equal to, this molarity is equal to 1000 into kappa. What was the kappa value given as? 1.382 into 10 to the power minus 6 divided by the lambda m naught value. What is the lambda m naught value? We got it as 138.2. Right? You will first solve this molarity part. This is getting cancelled, and when you solve this, comes out to be 10 to the power minus 5. It is 1.3 and this is, so 100 also will come there. So it will come out to be minus 5. This much molarity. But we are looking for the answer in this much gram per liter. So you will multiply this with the molecular weight of AgCl. Ag is 108 and chlorine is 35.5. So when you add up, it is 143.5. Right? So you solve it. You will get it as 1.435 into 10 to the power minus 3 grams per liter. This is the final answer. This is the solubility which we were calculating. Okay. So I hope this video was useful. Okay. Please practice the numericals. Thank you for watching.